So hello everyone, a very good evening to each and everyone out there, and I welcome you all to this amazing platform of PW Girls. So in this particular lecture, again we are going to do one more chapter in our ultimate recap. So in the previous lecture, we have completed a lot of chapters in our one shots, and here is the time for the chapter statistics. So what is statistics? Why is it important for our day-to-day life? Where is it used in our day-to-day life? So these are all the things that we are going to discuss in this particular lecture. So let's begin with our table of content for the day. So we are going to learn about the introduction, collection of data, presentation of data, the graphical representation, that is bar graph, histogram and frequency polygon. Along with that, we are going to learn central tendencies, that is our mean, median and mode, and some questions related to each and every topic. So let's start with this topic. So what is statistics, and basically what is data in statistics? So what is the population of the world right now? This is a data. We have to collect it. For example, you sitting in your class and the teacher asks you to count how many girls and how many boys are there. This is a data. For every test that you give, your teacher maintains a record for that. Now what is that? Again, a data. So basically, what are all these things that we have to take care of? So these are all the data. Now basically, the present day society is essentially information oriented. We need information for everything. Whatever survey that we have, whatever news that we get, that from the past 10 years the population has grown from this to this. How we are even able to compare with the help of statistics and data. So in various fields, we need information in the form of figures, that is known as data. So this is all about data, and the collection, interpretation and all these things associated with this data is what is known as statistics. So basically, the word data means information or a set of given facts in numerical figures, right? So the number of boys, for example, in your class be 20, the number of girls be 15. So that is what the numerical data. So for example, in maths, you have scored 15, your friend has scored 14, other one has scored 13. So this is what? Data. So this is all numerical data. So it is the science. What is statistics? It is the science which deals with the collection, presentation and analysis, interpretation of numerical data. In plural form, statistics means data. In single form, statistic is taken as a subject. So statistics is itself a subject, but when we talk about in the plural form, it means a collection of data. And when that data is collected, see, you have given a test. Your teacher got the marks, she gave you the marks, she collected your marks. After that collection, she arranges that in your report card. From that report card, see, one was what? Collection, that is the number. Second was presentation in the report card. And third is analysis and interpretation, that is how well you are doing. Either your marks have decreased from the previous UTs or periodics, or your marks have increased from the last test that you gave. So this is all about the analysis and the interpretation of the data. So we are going to learn about all these. So the very first thing that we are going to learn about is about the types of data. So there are two major types of data. One is the grouped, ungrouped or raw. The other one is the grouped data. Now what is ungrouped data? So basically, a data obtained in original form is called raw data or ungrouped. For example, the teacher first of all writes the marks in a sheet, that all right, Abhay got this much, Abhinay got this much, Siddharth got this much, and maybe Zainab got this much, Abiba got this much. So basically this is random, raw data. After this collection, she arranges it in a particular form, and we may condense data into classes or groups, such as presentation of data. For example, your class teacher wants to show those marks to the principal. Now she cannot just give that list. For example, the principal just want to see that how many are the average scoring students, how many are low scoring students, and how many are good or high scoring students, right? So basically, what will teacher do? If the test was of 15 marks, so teacher can group that from 0 to 5, how many students have got the marks? From 5 to 10, how many students have got the marks in this range? And from 10 to 15. So this is how, for example, in a class of 40 students, for example, 0 to 5 was secured by 5 students, 5 to 10 marks were secured by, for example, 10 students, and 10 to 15 marks were secured by your 25 students. So this is what makes a class of 40. So from here, from this data, it will be very easy for the principal to see that majority of the students are securing good marks, that is from 10 to 15. So ungrouped data is when I arrange, alright, one got 13, the other person got 12, one person got 11, the other got 5, the other got 4, the other got 15, the other got 12.5 and so on. This is raw data. Now when this data is arranged in any of the format like this with the intervals, these are known as class intervals. So this is what known as your grouped data, right? So let's start with the next thing, presentation of data, right? This is very important. In a fancy restaurant, when you order a dish, what matters the most is how they present it, right? So nowadays it is just like that, whatever it looks like appearance are deceptive, of course, but what we get to like is what the first impression and how is the presentation. What does it mean, first impression, right? If I enter the room, right, and if I am well dressed, if you are well dressed, if you are entering any room, that is what your presentation looks like. And presentation always have to be good so that the other person should know it, right? Even goes with the data thing. So for example, consider the marks obtained by 10 students. So these are just the marks obtained by 10 students and it is written randomly. Like for example, 55, 36, 95, 73, 60, 42, 25, 78, 75, 62 and so on. Now this type of data is what is known as your raw data, because this is just arranged. The numbers are taken and they are just written in a horizontal bar. But what if I just make a table out of it? This is a raw data. Now let's see one more example. For example, these are the marks out of 100 secured by 30 students. Now when I see these marks, I just see numbers arranged, right? Numbers written haphazardly. For example, 10, 20, 36, 92, 72, 60, 70, 60, 60, 88. So this type of data is a bit hard to understand. Right, it is clearly visible, I can only see numbers, but what do I get from it? Nothing, I just see the numbers, alright, majorly students have secured 80, 70, 70, 40, 40, 60, 60, 88, right? But exactly what I should know is not delivered with this type of data. Let's see. So what is presentation of data, students, is to actually arrange the given data in a specific form so that it becomes easy for the reader or for the looker to understand that thing and to interpret knowledge from that part. So over here, what is class mark? Upper limit plus lower limit divided by 2. First of all, let us see what does class mark means. For example, if I have to arrange this data, right, or if I have arranged this data as 0 to 5, 5 to 10, 10 to 15. So what is the class mark is? See, this is what is known as a class interval, that is 10 to 15, this is one class interval, 5 to 10 is a class interval, 0 to 5 is a class interval. Let's understand this concept, what is class interval again, right? So for example, over here we have what? 0 to 5, 5 to 10 and 10 to 15, right? So these are the class interval that I have taken to arrange the number of marks according to my class. I can also take 0 to 3, 3 to 6, 6 to 9, 9 to 12, 12 to 15 and so on. So basically these are the marks. So from 0 to 5 when we go, students, basically this whole is considered as a class interval. This whole is what is considered as a class interval. This is also considered as a class interval and this is also considered as a class interval. Now in this class interval that we talk about, this smaller value is known as lower limit. Lower limit. And this bigger value over here is known as upper limit. Right? Now for the 5, now over here the 5 is the lower limit and the 10 is the upper limit. Over here 10 is the lower limit, 15 is the upper limit. So this is what lower limit and upper limit means. Now what is class mark? The middle value of the class interval. For example, 10 to 15. What is the middle value? 12.5. How to calculate? We can calculate it by lower limit plus upper limit divided by 2. That is 10 plus 15 divided by 2, which is equals to 25 by 2, which is equals to 12.5. Now from 5 to 10, what do we calculate, right? So this is 5 plus 10 divided by 2, which is equals to 15 by 2, which is equivalent to 7.5. Over here we will get 2.5. So this is how we calculate the class marks. The next is class size. The difference between the upper limit and the lower limit. These are two different things. Class marks means upper limit plus lower limit divided by 2. Whereas your class size means the difference, the gap between the two intervals. Right? For example, over here, for example, the example that we have taken, that from 10 to 15, what is the gap of 5? From 5 to 10, what is the gap of 5? From 10 to 5. So generally we tend to take the exact class gap, class size in all the class intervals. Now the next thing that we have is again presentation me, right? We have the difference between the maximum value and the minimum value of the variate is called the range. For example, 10 students are given my test. So each, that was out of 15 marks. So one got 15, the other got 12, then the other got 13, one more 15, then we have 0. We have 5 marks, we have 7 also. After that we have 3, we have 15, we have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So basically when anyone will ask me the range means from the data the highest value minus the lowest value. What is the highest value? 15. What is the lowest value? 0. So the range of the data will be 15 minus 0, that is 15. Right? So this is how we calculate the range. Now the table shown is called the ungrouped frequency distribution table or simply a frequency distribution table. Now basically the teacher can also make a table like this. For example, these are the marks which the students got, like 10 marks were got by one student, 20 by one, 36. So from the data that was previously mentioned, which was here, now this data and when you will see this data, you can clearly see that which one is more informative. So you are clearly able to see and get knowledge from this data that alright, 10 marks were also secured, that means 10 were the least marks. 95 was the maximum marks any student have got, and also we can see that majority of students got 70, 60 and 40 marks. That means 4 of them. So the number of students or number of anything that particular thing acquires is called the frequency. For example, in a day I go to the gym twice. So that becomes 2 times. That is frequency of me going to the gym. In my class, 7 students have secured full marks. That means 7 is the frequency of getting full marks. So this is how we get the thing. The next thing, let's go to question. So it says the blood group of 30 students shown of class 8 are recorded as follows. Represent this data in the form of frequency distribution table. So for this, what we have to do, we have to make a table that is known as the frequency distribution. That means this is by this many students, this is by this many people, this thing is by this many people. So we have these many blood groups, that is A, B, O and AB. These are the 4 blood groups that we can see. Write down blood groups. Now that will become what? A, B, O and AB. Right? So what we have to see that how many people have A blood group, how many people have B blood group, how many people have O blood group and how many of them students have what? AB blood group. So when we talk about blood group A, so we have 1, then we have 2, 3, 4, 5, 6, 7, 8 and 9. So 9 people have A blood group. This is frequency. The next is B blood group. So 1 student, 2, 3, 4, 5 and 6. So 6 people have B blood group. Then we talk about O. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 people have O blood group. Now we are left with AB1, AB2 and AB3. So 3 of them have what people? 3 of them have AB blood group. Now let's add up, and they should add to the total amount of students. 9 plus 6, 15 plus 12 and 3, that is 30. That gives us, alright, we haven't skipped any of the data. So now it is asking which one is the most common and the rarest blood group. Most common, as we can see, is O blood group, and most rarest we can see is the AB. So from this data, it was a bit hard to find out which one is common and which one is the rarest. But when we arrange it in a frequency distribution, this will tell us exactly and more clearly that which one is the most frequent one and which one is the rarest one. The next thing that we have over here is the graphical representation. Now see, one type of presentation is frequency distribution table. The other type of presentation is the graphical representation. For example, to draw the graph, that means let this be the y-axis, let this be the x-axis. For example, we are talking about population, right? So we can say that in 2015 the population was this much, and in 2019 it came up to this. Now in 2023 it came up to this. So from this data, without even seeing any numbers, it is very clearly visible that the particular amount of population that we are talking about is growing year by year, right? It is growing year by year. So this is what we have. We know that this is a bar graph. So this is one graphical representation. In total, there are 3 graphical representation. One is the bar graph, the other one is the histogram, and the third one is the frequency polygon. So the frequency polygon might not be coming in some of your school, but let's study, all right? So this is the bar graph. As we can see, expenditure in 1000 rupees is on y-axis, and the things on which we are spending is mentioned on the x-axis. So basically this 1 means 1000, 2 means 2, 3000, 4000, 5000, 6000 and 7000. So from the graph, it is very clearly visible that on rent and education, the highest amount is spent. Then the least amount is spent on entertainment and miscellaneous. Medicine and fuel share a common expenditure. So from the bar graph, student, it becomes more clear, more presentable, more analysis oriented, and we are able to get more information with less time, right? So let's move forward and draw a bar graph. So for example, this is given below are the seats won by different political parties in polling, outcome of a state assembly election. So seats won by party A is 75, party B 55, 37, 29, 10 and 37. They are asking draw a bar graph for the polling results. So what we have to draw? We have to draw the bar graph. So what we have to take, students? We have to take a x-axis, right? This is our x-axis, and for the next we have to take a y-axis. Now this is our x-axis, this is our y-axis, this is our x-axis. Now we have 5 parties, right? So party A, 6 parties from A to F. So let's mention this as the origin O. Let this be for party A. Let this be for party B. Let this be for party C, party D, party E and party F, right? So what we have done with the gap, we have just plotted the parties. Now since the seats won, so basically we have to take a scale. How? In the previous example that we just saw, they took a scale. That means each one unit gives 1000 rupees. That is up to us. What scale do we have to choose according to the numbers that are there in front of us? So we can take a scale of 5. We can take a scale of 10 as well. So let's take a scale of 10. That means what? That 1 unit over here represent 10 seats. What does it represent? Each one unit over here represent 10 seats. So what we have to mention? We have to mention the scale, right? Then on that, on y-axis, we have taken 1 unit is equivalent to 10 seats. So this is what we have to mention. The next thing, let's draw the graph. For example, seats party A won 75 seats. 75 means in between 7 and 8. So we will just draw the graph and it will go in between 7 to 8. So this will give us what? 75. The next thing we have is 55 and then 37. Party B has got 55 seats. That means in between 5 and 6. So party B has got how many seats? 55. Party C has got 37. That means somewhere above 30, right? Somewhere above, just above 30, a bit. When you will draw on the bar graph, it will be more accurate and you can take the scale as per your own wish. If you want to take a scale of 2, you can take a scale of 2. If you want to take a scale of 5, you can for sure take a scale of 5. The next thing that we have is for the D, E and F. So D got 29, 10 and 37, right? 29 will be, students, somewhere below 30, just 30, right? After 29 we have 10 and 37. So 10 is very simple to draw. 10 is just 1 and then we have F as 37. So we can draw it as 37. So this is how we can draw, and from the graph it is very clearly visible that seat A got the that the party A got the maximum seats, party B got the less than A, then party E got the least number of seats, and we can come to a conclusion. So this is how we draw a graph. So you have to mention the x-axis, y-axis, what you are taking on the x-axis now. So what you have taken on the x-axis, that is parties. What you have taken on the y-axis, that is number of seats. Now, what you have taken on the y-axis as a unit, that means you have to write it down. Clear? So this all ends up to your bar graph. The next thing that we have is histogram. So histogram is something, students, when the data is continuous. See, when we talk about bar graph, the data is non-continuous. What does non-continuous mean? That there are no class intervals like 10 to 20, 20 to 30, 30 to 40. That is not there. What is there is groceries, education, medicine, different commodities. What is there? Party A, party B, party C, party D, different, separate things. But when we talk about histogram, that means one continuous data that is in the form of your class interval. So the over here, as you can see, here to here represent 30.5 to 35.5. From here to here it represents 35.5 to 40.5. From here to here it represents 40.5 to 45.5 and so on. So this is continuous. Just where the other ends, the other one starts. Just where the first ends, the other one starts again. So this is what is known as histogram. And in the starting of histogram, students, if, see, what is the zigzag line? Right, from 0 we are going to 30.5 and then from 30.5 we went to 35.5, 40.5, right? So that is a direct jump from 0 to 30.5. So to cover that jump, we make this kink to denote that the data over here, this is a very big gap, and then from here the gap is continuous. So to mention that big gap, we make a kink. For example, you went from 0 to 10, 10 to 20, 20 to 30, then you do not have to make a kink because 0 to 10 is the same gap, 10 to 20 is the same gap. But if you are starting, for example, you are giving marks like you are just writing something which starts from 100. So there is no point, like it goes from 100 to 110, 110 to 120, 120 to 130. So there is no point to show that 101 part. Right? There is no point to show that 0 to 10, 10 to 20, nothing which is starting from 100. So you just skip that part and you make a kink so that it denotes the gap. Now let's move forward to the next part, that is the frequency polygon. Now what are frequency polygons, students? When we plot a histogram, right, and for that histogram, if we just connect the midpoints of that histogram, it forms a frequency polygon. So for example, this part is given to us. Right. Now, if I have to draw a frequency polygon, that is through histogram. Now, what I have to do is just join the midpoint of this bar, 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 and midpoint of this bar. So, when I just join all these points, students, this resultant figure will get us a what? Will get us a frequency polygon. As simple as that. Right. For example, here's a question. So what we have to do, we have to make a frequency polygon for section A and section B both together. The following table gives a distribution of students of two sections according to the marks obtained, 0 to 10, 3. Now let's plot. See, the marks are from 0 to 10, then 10 to 20, so no need of kink. Let's draw the graph. Right. So this will be our x-axis and this will be our y-axis, right? Mention x-axis, y-axis. It goes from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 60 and 70. Right, this is one thing, that are the number of marks. And then the frequency, as we can see, it is just going up till 19. So we can take a gap of 2 also, right? So basically 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So basically for the scale we have to write down that on y-axis 1 unit represent 2 students. Now let's draw for school 1, right? Let's do it for school 1. So basically 0 to 10 is 3. So you just have to see that from 0 to 10 it is 3. So in somewhere between 3. Then go for 9, 17. Then you have to 20, 10 to 20 is 9. 9 will be somewhere in between. See, sorry, 3 it was, I'm so sorry, if it was 3, right? 3, see, since 1 is representing 2, so over here will come as 3. The other one that we have is 9, 17. Then from 10 to 20, it's 9. That means 4 is 8 and somewhere over here is 9. Then what we have is 17. That means 7 2s are 14, 16 and in between this you will be getting 17. Now after that we have what? 12 and 9. So at 6 we will have 12, from 30 to 40 at 6, and then we have from 40 to 59. That is 40 to 50 in between will give you 9, that is 3. Now what you have to do, just join them with the free hand. Join, 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 join. Right? So these are the 5. Now the next is what? 5, 19, 15. So where will 5 lie, students? So from 0 to 10 it's 5. So 5 will lie in between over here. After 5 we have 19. 19 will lie somewhere between 9 and 10. That means over here. Right? Then after 19 we have 15, 10 and 1. So 15 will lie in between your 7 and 8. Over here is your 15. Right? After 15 we have 10. 10 will lie at 5. That means over here. And then we have 1. That means very low. Over here somewhere. Very low. Right? So this is how we plot it. This is how we do it. And in the same graph we can draw 2 frequency polygons. Now let's move forward to the next part, that is the central tendency. Now what are central tendencies, students? From that data, what values we can get for like average, the mediocre, the median, or what is occurring the most number of times. So when over here we talk about, students, when we talk about simply our mean. Mean means what? As simple as that, sum of observations upon number of observations. So when we talk about mean, students, let's see a question. this is what? Find the mean temperature. That the temperature on Monday was 35.5, on Tuesday 30.8, then on Wednesday it was 27.3, on Thursday 32.1, Friday 23.8, Saturday 29.9. So what are they saying? Mean temperature. Means mean what? Sum of all observation divided by number of observation. That is 1, 2, 3, 4, 5, 6. How many observations are there? First of all, the sum of observation, that is 35.5, 30.8, 27.3, 32.1, then we have 23.8 and 29.9. So what we will get? See, 9 and 9, 18. Then we have what? 18 and we have 18 and 3. That means we have 21, 21 and 8 we have 29, 29 and 5 we have 4. That means 34. Then over here what we have is, just add them up. So we will be getting 9 and 9, 18, 18 and 3, 21, 21 and 8, 29, 9 here, 2 here. Then we have what? 2, 2, 4. Then we have 4, 3, 7, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So what we have? We have mean is equals to sum of observations, students. Sum of observations divided by number of observations. So what is sum of observation? 179.4. What are number of observation? That is 6. Now divide this by 6, whatever decimal you will be getting the answer. So basically 179.4 divided by 6. So basically 6 2s are 12, students, minus we have 5, 59. Then we have what? 6 9s are 54. Then we again have 0, 5, 54, 29.9. So what is the mean or average that we talk about? So this is the average temperature, that is 29.4. So this is how we get the average. The next thing that we have over here is, see, if the mean of the 5 observation, now in such type of questions the mean is already given, you just have to find the unknown value. Find the value of x and hence find the mean of the last 3 observation. So what is mean? 5. And what is actually the mean? 13. We know that mean, which is denoted by x bar, is equals to sum of observations, students, divided by number of observations, right? What will be the sum? That is x plus 2 plus x plus 4 plus x plus 6 plus x plus 8. Now this is the sum. Number of observation is 5 and the mean is already given to you as 13. You just take this 5 and multiply. So this will become 65 is equals to 1, 2, 3, 4, 5. 5x, 2 plus 4, 6, 6 plus 6, 12, 12 plus 8, 20. This will go there. It will become 45 is equals to 5x and the value of x comes out to be 9. Now when the value of x is 9, so the data becomes 9. 9 plus 2, that means 11. 11, then we have 9 plus 4. Right, that will be 13. Then we have 9 plus 6, that will be 15. And then we have 9 plus 8, that will be 17. Now what we have to do, we have to find the mean of the last 3 observation. Now for the last 3 observations, students, it will again become sum of observations upon, now the number of observations is 3 because we have to find the mean of the last 3 values. So this will become 13 plus 17, that will give you 30. 30 plus 15 is 45 and 45 by 3, that will give you 15. So the mean of last 3 observation, that is the average of last 3 observation, will come out to be 15. So this is how we deal with the question of mean. Now let's talk about median. Now what is median, student? Median means the middlemost value. Like for example, see. For example, we have 5 students. If I asked you to find out the middle one, that means this observation. right? So basically what is median? The middlemost observation. For median student, it is very important for you to know that first arrange the data in either the ascending order or the descending order. What you have to do? Either you have to arrange the data in ascending order or in the descending order and then find the middlemost value. See, there are two types of things. For example, when the n is odd and for the n is even. For example, now the number of students is 1, 2, 3, 4, 5, 6, 7, 8. Alright, what's the difference? Over here, the number of students is odd, that is 5. In this case, the number of students is even, that is 8. When it is odd, it becomes really easy. What you just have to do is n by 2th observation. What you have to do is that you have to just calculate the n by 2th observation. Now what does n by 2th observation means? See, this is 1, 2, 3, 4, 5. Right? Now since this is odd, just add a 1 to it. What? N by 2 plus 1. See, what is n? 5. So how to calculate the median? 5 plus 1 by 2, which is equals to 6 by 2. That means third observation. See, this doesn't mean this is the median. This tells you which observation is the median. That means third. That means 1, 2 and 3. This observation will be the median. Now in this case, when the n is odd, you just have to do what? First you have to calculate the n by 2th observation. Then you have to calculate the n plus 1 by n by 2th observation plus 1. Right? You just have to calculate n plus n by 2 plus 1th observation and then add both of them and divide by 2. That means what? See, first of all, what is n by 2 over here? That is 8 by 2, which will give you 4. What is n by 2 plus 1? That means 8 by 2, that is 4 plus 1, which is 5th observation. Now, what you should see that this is the 4th observation. This is the 5th observation. Now, in between 4th and 5th observation lies your median. So, you have to find out a number in between. So, median is not always like it should come in that data. It can come aside from that. Let's see one question. Right. So, this is what I have told you. When n is even, you have to do this. See, over here we have to calculate median and these are 10 teachers. 10 means n is equals to even. The very first thing, students, is to arrange the data in ascending or descending order. Let's arrange in ascending order, which is the smallest over here. I guess 32. Right. After 32, we have 34. Then we have 36. Then we have 37. 34, 36 and 37. After 37, we have 40. Then we have 44. We have 47. We have 50 and then we have 53. So these are what? Ascending order. Now we know that the n is 2. That means n is 10, which is equals to even. So basically, how we will calculate the mean? First of all, we will calculate n by 2. That means 10 by 2th observation, which is 5th observation. Next is n by 2 plus 1th observation, that is 10 by 2 plus 1, which is equals to 5 plus 1, that is 6th observation. Now we have 5th observation, then we have 6th observation. Now in this case, what we have to do now, add both of them. Now how to calculate the mean? 5th observation plus 6th observation divided by 2. That means 1, 2, 3, 4, 5th observation, 6th observation. That means 40 plus 44 divided by 2, 84 by 2, which is equals to 42. What is the median age, students? The median age is 42. So then what we do is, if n is 16, the mean is the middle value of the mean of these two. Right? That means the middle value of these two we have to calculate. When it's odd, it's very simple. Arrange in ascending order, find n plus 1 by 2, 6th observation, calculate first, second, third, fourth, fifth, sixth. This observation, this is the median if the n is odd. Easy. Alright, let's see mode now. What does mode means? The number which is coming more number of times is mode, as simple as that. Just MODE is mode, right? Now just do this. More. The number which is coming more number of times is the mode for the data. In this data, what is the mode, right? See, we have 0, 6. As we can clearly see, this 6 is coming 4 times. Any other number is not coming 4 times. Since this 6 is coming 4 times, we will take that the mode of this given data is equivalent to what? Simple 6. Clear with it? Let's see one more question of this. Right? Now over here, determine the mode of the data. What you just have to see is, look at the data, see that which number is coming more number of times. So over here, as we can see, 23 is coming 1 time, 15 is coming 1 time, 25 is coming 3 times. And since 25 is coming 3 times, this is what known as the mode of the data. As simple as that. Right? So one more question for you people as a homework, and do comment down the answer down there, and if you have any problem and any issues in this chapter, do let me know. Right? So this was all for today. This was all for statistics. So do practice the question, and if you have any doubt, do let me know. So thank you so much everyone. I'll see you in the very next ultimate recap. Till then, take care. Have a great time ahead. Bye bye.